Hello grade 11s and grade 12s. So today I'm still doing a functions video, but these are more advanced um, functions. So the first two videos I did the ones that accommodate grade 10. Well, that's like a basic functions. So now we are taking it up a notch a bit, where the equations are not the same. They have added a few things to the equations to make them a bit harder for the higher grades. So without wasting any time, let's get into it. So here we are firstly going to look at a parabola. This is the graph. We're having this graph to work with. Now this graph is represented by this alphabet. If you are asked to determine the equation of the graph, you'll be given something like this, and then you'll be given a graph, and then you'll be told from that graph that you are given, determine the equation of that graph. The equation will be this follows. It will be f at x here, g at x, or h at x, but it's the same thing. F at x, g at x, h at x is y. They are all a representation of y, just that in functions they are written as f at x, h at x, or g at x, or whatever the examiner might gravitate towards. So this one, which is this q, tells if the graph has went up or down. Remember, a parabola is that graph that is happy or sad. So when you're talking about a parabola, we're talking about that graph. So this q would represent if the turning point has went up or down. When it's at origin is when x is 0 and y is 0. This is the graph. The parabola graph at origin is like this. It's sitting here on 0, right? When it has went up, let's say 1 unit up from here, and let's say this is 1. You see? So do you see how you'll be able to determine the equation of this graph? If the graph didn't shift up at all, we don't have a plus anything, it's 0. So we do not have this 1, right? Because the graph didn't go up, or the graph has went down. When the graph has went down, it's a negative. Here the graph has went up, it's a plus when you're trying to draw that graph with that equation. But here, when it has went up, it's a plus 1. Let's say it's a 1. Like here, this side it has went down. So when it has went down, it's a negative 1. That q, for you to know whether the graph has went up or it has went down, you will know by this sign. If it's a plus, it has went up. If it's a minus, it has went down, right? So let's go to them. Okay, so let's go to this 2, which is represented by P. The 2 tells if the graph has shifted left or right. If it's a negative, like this is a negative, the graph has shifted to the right. So if it's negative, the graph has shifted like this to the right. When we have a negative 2, with this represents x. So when you have this on the graph, know that when it's negative here, it's positive on the graph. When it's positive here, it's negative on the graph, right? So it means the graph has shifted to the right, because there it's negative 2 times. From origin, it hasn't 1, 2, right? So if it was a plus, it means the graph has shifted to the right 2 times. It will be 1, 2, right? So this is the origin, and here are the different shifts that the graph can go through. So this is a represented by A. If A is negative, the graph has to face downwards. But if A is positive, the graph has to face upwards. We need a smile. and when the graph is on A is negative, the graph must be sad. So this is your value of A. Now here you can see, hey, A is 1, so we do not write 1, right? Because it will still be the same. 1 times x, it will still be x. So here we have A as 1 as positive 1. Now, which means this graph is happy. So let's move on. If, yeah, we are done with all of that, now we are here. Now we are here, y equals to x squared minus 4. So what has this graph done? This graph has moved how much? These are the things that you have to know. You see this x squared here, which means this graph has neither moved to the left or to the right. It's standing at origin there, but it has moved 4 units down by this negative. So the squared, the x squared is here. So you must know that this is q. So we just have a here and q. There's no p because this graph is still at origin. I didn't move left or right. It's just moved 4 units down from origin. So let's see this one. Y equals to x minus 1 squared minus 4. This graph has moved 1 unit to the right. Remember, when it's negative here, it moves to the right. When it's positive, it moves to the left. So here, this unit has still moved 4 units down. This graph has still moved 4 units down. Here, we have a negative a. So this graph, it's sad, it's facing down. It has moved 1 unit to the right and 4 units up, right? So it's like this, 4 units up from origin because it's also sad. Now we have x plus 4. This graph has moved 4 units to the left like this. It is standing somewhere here, right? And then we do the 3 units up. That will be something like this. This graph is somewhere there, right? Now we have moved. I hope you understood how to interpret the graph using that P, Q, and A. Now here we're going to learn how to draw a parabola, right? Sometimes you can be given the equation of a parabola in the form of a quadratic equation. They will say f at x is equals to x squared minus 7x minus 5. This is a quadratic equation. So in this point, you are not given this graph in a turning point manner. If you're given this graph in a turning point, we have this. These 2 points are our turning points. Now we don't have turning points here. We have to find values of x, y, and then calculate our turning points ourselves. It's not given. So when you find a graph like this in your exam, don't be alarmed or like, what is this? It is still a parabola. So a parabola is a quadratic equation. If you take this and you expand it, you will still get something like this. But for you, in order to go from here to this equation, you have to complete the square. So it simply means if you want to find it in this manner, you have to complete the square. But it's not really important to complete the square, but you can if you want to go back here. If you say, I want this whole equation in this manner, you'll have to complete the square. So let's solve and see how we are going to draw a parabola if we are given this quadratic equation. Now we use the quadratic formula. This is b, 7, using the value of b. This 5 represents c, and this value here represent your b, yours a, sorry, a. So if it's not written, anything is just x squared, which means it's 1. I hope you know that. So it's a negative b plus or minus b squared minus 4ac over 2a. This is a square root. Now you substitute everything into the formula just like I have done here. This formula comes with a negative, and this 7 is also negative. So you are going to put the 7 here. Don't forget that. And then you get the two values of x, which is 7,65 and negative 0,65. So here, y is 0, right? You're going to say 7,650 and negative 0,65 and 0 for what? The y value is the x-intercept on the graph. You will see, so to get y, x has to be equals 0. Now you are going to replace x with 0 on this equation to get y. Let's do that. So we are going to say 0, sorry, bracket, open bracket, 0 squared minus 7 into 0 minus 5. And then you will get the value of y as your negative 5. All right, here it is. We got our negative 5. Now we have the value of x and the value, we have the value of, you have our 2x values. That's what we need for a parabola. You need 2x values. You need your y value, which is negative 5. And then we need to calculate turning points. Now, for the turning points, when you are given a parabola in a form of a quadratic equation, it's negative b over 2a. You get your turning points in that quadratic equation that you are given. So, this is a formula for the turning point. The x value of the turning point, we get it by, say, negative b over 2a, right? That is how we get the turning point. Now, here we substituted b was a negative 7. So we have to, that is negative for the equation, remember that, and this is the negative for the 7. And then we divide that by 2, and a was 1. So when you put that into your calculator and say negative 7 over 2 times 1, that will give us 3,5, or 7 over 2, right? So that is the x-intercept of the turning point. And then we are here, we sub this 3.5 into the original formula to get the turning point, the y value of the turning point, right? We've got the x, now we have to calculate the y. So how do you do that? You say 3,5 squared minus 7 into 3,5 minus 5. And the answer is negative 17,25. So the coordinates of the turning point is 3,5 for x and negative 17,25 for the y value. Now we've got the x, the 2x values, we have the y value, we have the turning points. Now we can draw this parabola. So when we have turning points, guys, different turning points, it means that this graph is not turning on origin. The curve has shifted. Here we have experienced a shift either to the left or to the right, but the only way to find out the shift that we have experienced here, we have to draw the graph so that we can know what is happening here. So let's go. Here I have a graph. Let me just we have the graph here and we have to draw. Now the first thing that we need to do is to mark the x, the 2x coordinates we got using the quadratic equation in the beginning, which was 7,65 and 0 and negative 0 and 6, negative 0.65. So on the negatives, we have, before we get to 1 here, we have negative 0.65 and 0. So this is the x value, and this is the positive x value, that is 7. So I'll take it here. That will be 7.65 and 0 here. And then we need to plot in the y value. So the y value, we got it as negative 17.25. Let's say that is somewhere here. So that will be negative 17.25 and 0. And then the turning points of that y value, we found them as well as 3.5 and negative 17.5. So we are still here, but we are gonna move, we're gonna come like, then we're gonna turn here and go, because this is 3.5, right, for x, and negative 17.25. All right, so we've got 3 points there. Let's say the 3.5 is here, and then yeah, this is the 17 still on the same line as that one. We have to go like this graph has to go like something like, I think I took this 17 down, but it has to go like, you see, the diffuse is one eye to go down. All right, I tried to perfect the graph, guys. So here it just has to pass here, but the turning point is here, right? So the turning point is not here. This graph has shifted to the left, to the right, sorry, has shifted to the left, 3.5 to the left, to the right, sorry. So that is how the graph would look like. All right, when we are given this equation, y, or f at x, g at x, h at x equals to 2 x minus 1 squared plus 4, the turning points are this. So this is going to be 1 and 4. When it goes to the equation, when it's negative, it's going to be positive. When it's positive, it's going to be negative. So it's a 1 and 4, because you know how many times it moves up and down, and if it also moved left or right, because we know it has moved 4 units up, it has moved 1 unit to the right. So that's what we know now. And then another thing that you know is that y equals to, there are turning points with this equation, and there are no turning points with this one. You have to look for turning points using that negative b over 2a equation to find the turning points of x. When you find them, you substitute them into this. When you find the turning point of x, you substitute it in here and find the turning points of y. And then it's just as easy as that, really. When there are no, and it happens that sometimes there are no x coordinates. You see, you can just say and expand this bracket. Look, where does it take you? It takes you here. It takes you back here, where you have a quadratic equation, when you just expand this and then solve. All right, now we are given this graph and we are asked to determine the equation. This is your turning points. So you already know there where which ones are your turning points. So Q equals to -2 and P equals to -3. When it's positive here, it's negative on the equation. Remember that, guys. So we just have to find A. So we are going to substitute these values as x and y. Here, this is the equation: y equals to a x plus p squared plus q, right? So where a is equal, y is equals to a x minus 3 squared minus 2, right? When we substitute the turning points. Now we need the value of a, because x and y has to say like this. We substitute the 5 and 10 on the graph, and then we'll say 10 equals to a 5 minus 3 squared minus 2. Now here we are, this 2 will move this side. 10 minus 2 equals to a 5 minus 3 squared. So this is where we will find ourselves. So what we will do, this is 8 equals to a, we'll deal with this bracket and say 5 minus 3 squared, and that is 4. So 8 equals to 4. A divide by 4 on both sides, and then 8 divided by 4, that gives us 2 equals to a. So you see, we have determined that, and then the equation will be y equals to 2x minus 3 squared minus 2. All right, now we are at hyperbola. This is the equation of the hyperbola. All right, here we have it. Now it's 3 over x minus 1 plus 4. So these are asymptotes. This is the y asymptote, and this is the x asymptote. When it's negative here, it's positive on the graph. It cuts at +1, but when it's positive here, it cuts at -1 on the graph. This one will always be the way it is. If it's negative, it cuts at negative. If it's positive, it will cut at positive. So let's say here we are having a hyperbola graph. This, when a hyperbola is cutting in quadrant, when it's in quadrant 2 and 3, it's a positive hyperbola, and when it's in quadrant 1 and 4, it's a negative one. So if we are having a negative here, it has to be in this ones. If we're having a positive like we're having here, it has to be in these two ones, right? So for the asymptote, this is the equation: 2 over x plus 3. This line, focus, this line cuts at a +3. So it will cut here, and this one will come up here, and this one will come down here. It will go up. This one has to be in this quadrant, but because this thing has shifted the graph up, which means this graph has went up on top of that 3, whatever that is here goes up, whatever that is here goes high. This one has to be on top of this asymptote. This one has to be just beneath the asymptote. So if there was x, you will also cut at x. So here we have our equation. So let's say this will be something like this. Will cut at, we will say y equals to 4, and then it will cut at 1 here. Then x equals to y. This is the equation of the asymptotes. Then this graph will go this way and will go this way. This asymptote has pushed it to go this side, and this one has. So we have that That's the axis of symmetry here. But do you see it? This is the graph of this equation. Here it is. Yes, we see length asymptotes. So with that information that we have just gotten, we have to know how to draw the graph. So this is how we draw the graph. We need to get x and y. So to get x, y has to be 0, and to get y, x has to be 0. So firstly, we want to get y. We're just gonna to get or let's start here. I started with how to get x, so let's just get x. So y will be 0, and then we have to solve this. This y has to go this side. When it's this side, we have to cross multiply, so it will be -1 times x minus 5, right? This one has to go this side, and then we have -1. This will cross multiply, or we can times by x minus 5 this side and times by x minus 5, and then that x will cancel this one. Then we'll still have the same thing, really. The way we're gonna is like this: 1 over, yeah, so -1 equals to 2 over x minus 5. We can say times x minus 5 here as well. We times x minus 5, and then this cancels this, and then we're still gonna have x minus 5 times 1 divided or equals to 2. We're still gonna get here. So that is another way you can solve that instead of cross multiplying. Negative x plus 5, when you times this x becomes negative, and then this becomes positive over 2 equals to 2. Then this x, because it's negative, let's take it to this side, and then take the 2 this side. Then our x equals to 3. And then this is what we do. To get y, we make x 0, and then we get y as 3 over 5, which is 0,6. Now let's try to draw this graph. All right, so let's plot. The first one we got was 0,3. We got x as, oh, not 0,3. We got x as 3. Firstly, wait, let's draw the asymptotes. So the asymptotes here was -5 and 1. So this -5 turns into +5. So on the x-axis, it's going to cut here. This is the equation. When it's negative, it's positive on the graph. This one remains the same. All right, it cuts there. Now it also cuts at +1 here. All right, so it has cut at 1 there, and then now we have to look at the x-intercept. X-intercept we got here 3 and 0, and another one we have y as 0,6. 0,6 is somewhere here, so that's 0 and 0,6, right? So here are the two intercepts that we have, and now this graph will go like this. Yes, so we have that asymptote, this asymptote, and we have the two intercepts, and this graph will just be going downwards like that. It will just go like that. So when you're asked to determine the equation of the graph, this will be written as P and this one as Q. But on the graph, you will have asymptotes. So you will eventually, I didn't draw the graph. I'll show you when we do question papers. That graph will have asymptotes like you have above. So you just write the y asymptote and the x asymptote, right? And then you will be also given values on that graph. So in this graph here, we're given the values as 2 and 3, because there are other exercises where you're not even given a graph, you're just told what is happening. You'll be given the asymptote of x equals to, the equation of the asymptote of x equals to -2, and the equation of the asymptote is equals to 2, sorry, and the equation of the asymptote of y is equals to 1, and then you are given the coordinates, and then you just have to draw the graph. So you do, they will not always give you a graph for you to determine the equation. They can just tell you what is happening and you know what to do. So y equals to a over x, or -2. When it's positive on the graph, it's negative on the equation, remember, plus 1. So you substitute these values 2 and 3 to get a. With this, you will move this one this side, right? Or you can leave it here. I moved it at a later stage. Well, here I just said I did 3 minus 1. This is 1, so a over 1 is 1. So that will be a over 1. It's still 1. So I got 1. I got a plus 1. Then this one moved to this side. You can move it earlier now. Then it's 2 minus 1 is 1. So a equals to 1. So the new equation is y equals to 1 over x minus 2 plus 1. That is the equation. So here we are looking at exponential functions. In grade 11, you'll not be asked to find the value of x. You will only be asked in grade 12. So they will only look for the value of y. For you to get this down, you have to use a log. So log graphs are in grade 12. My next video will probably be dealing with inverses, how to use logs to get that down. But in grade 11s, we don't use logs. So you just be asked to really do y. I hope you watched the one for grade 10. I did a bit of things there. So this is how you have to find y. You just make x 0. We're almost at the end of this video. We're just going to deal with domain, range, reflection, and translation. So when we ask for domain, domain is the x values and range is the y values. So for hyperbola, which is what we've just done, domain and range is dependent on the asymptotes. So when you have your asymptotes, you will be able to determine your domain and your range, right? So for a parabola, domain and range are dependent on the turning point, just like I had shown you. So are dependent on the turning points for a parabola, right? So let's say for asymptotes, you will just check at the x asymptote, and then for the range, when you're dealing with a hyperbola, and then you will look for the y asymptotes for the range and the x asymptotes for the domain, and then you write it like this. All right, let's say for instance that the asymptote of this graph for x equals to 2 and y equals to 1. So you are given, this is the equations of the asymptotes, right? Remember the graph, this is negative on the equation and the graph is positive. So for domain,